Alright, so today we're talking about CPCTC. It's just an acronym that we use for corresponding parts of congruent triangles are congruent. So once I know triangles are congruent, then their corresponding parts must also be congruent. So we can use CPCTC as one of the steps in a proof. For example, this one says, given that BP bisects angle ABC and triangle ABC is isosceles with AB congruent to BC. That's all that we're told. We have to prove that P is the midpoint of AC. Okay, so let's start with the given. Given BP bisects ABC. I just rewrote all the given, put there. Okay, now, because it's a bisector, I know that these two angles have to be the same. So I'll call one angle 1 and I'll call one angle 2 just so I can give it a name. So then angle 1 must be congruent to angle 2 because the definition of angle bisector. Okay? So now BP must be congruent to BP. So BP in this left triangle is congruent to the BP in the right-hand triangle. So BP is congruent to BP by the reflexive POC. Okay, so now I can say that triangle ABP is congruent to triangle CBP by side angle side. So if I look here, these two sides are congruent, these two angles are congruent, and this side equals itself. So by side, angle, side, I have congruent triangles. So now I can say that AP is congruent to CP. AP is congruent to CP because remember these are congruent triangles. We just showed that. So how do I know that AP is congruent to CP? Because they are corresponding parts of congruent triangles. So that's how they must be congruent. And I'm trying to show that P is the midpoint of AC. Well, I've just shown that AP and CP are the same. So then P must be the midpoint of AC because of the definition of midpoint. And again, if we don't totally understand how this works, we'll do more examples in class. But again, try to have a sense of how these proofs work. Try this next one on your own. Pause the video. See if you can get it on your own. Again, you'll learn more if you're trying on your own than if you're just copying down what I'm doing. I start with the given, like I always do. B is midpoint of AD and CE. Give us, I mark up my picture, so I put one tick there and one tick there. And I put two ticks and two ticks. Well, I also know these are vertical angles, so I label them. I call that one angle 1 and I call that one angle 2. And I'm trying to show that CA is parallel to DE. Well, AB is congruent to BD and CB is congruent to BE because of the definition of midpoint. I know angle 1 is congruent to angle 2 because of their vertical angles. So now I can say that triangle ABC is congruent to triangle DBE because of side, angle, side. Side, angle, side, congruent to side, angle, side. So if the two triangles are congruent, then my corresponding parts must be congruent. So therefore angle C must be congruent to angle E because of corresponding parts of congruent triangles are congruent. But now if I look, these, I have two lines right here, AC and ED, being cut by a transversal. So that makes C and E alternate interior angles. And so if C and E are congruent, then by the converse of the alternate interior angles theorem, CA must be parallel to DE. Alright? That talked about CPCTC. Now let's go over isosceles triangles. So let's be sure that we're clear about this. So, vocab. If this is my isosceles triangle, my two legs are the two sides of the triangle that are congruent to each other. So this is congruent, so these are my legs. My base is the other side of the isosceles triangle. These are what we'll call the base angles because they're angles made by one of the legs and the base. and we call this one the vertex angle. So be sure you understand this picture. Alright, vocab. Legs of an isosceles triangle, they are the congruent sides of the isosceles triangle, like we just said up here. If these two sides are congruent, those must be the two legs. The vertex angle, it is the angle formed by the two legs, right there. Vertex angle is the angle formed by the two legs. The base angle, it is the side opposite from or across from the vertex angle. So if that's the vertex angle, the base is right here. Alright, let's see. The base angle. The base angle, they should say base angles, that should be plural. The two angles that have the base as a side. So base angle because they're made with the base as one of the sides of the angles. Alright, isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite from the sides are also congruent. So I've got a little picture over here. Alright, there it is. So if these two sides are congruent, then the two angles opposite from those sides must also be congruent. So this angle is opposite from this side, this angle is opposite from that side. So if these two sides are congruent, these two angles have to be congruent, whether it tells you that or not in the picture. If it tells you these sides are congruent, we have to know that these angles are congruent. And the converse is also true, so it works the other direction too. Converse. If two angles of a triangle are congruent, then the sides opposite those angles are also congruent. So if I'm given this picture and they don't tell me that these sides are the same, but they tell me these angles are the same, then I have to know that these sides are the same. Examples to follow in class. Okay, here's a proof. I'm not going to go over this one in too much detail other than to let you see the picture, what I marked up. There's my reasons, there's my statements. If you want to pause and copy that down or try to do it on your own, go ahead. But there it is. We just proved the isosceles triangle theorem. Okay, so now how do we actually use that? It's pretty simple. This one, it says find the value of x and the measure of a. Well, if that's got a tick and that's got a tick, it means these two sides are the same. Again, that means whether it tells you or not that these two are also the same. So I can set 3x equal to x plus 44 because these angles have to be the same. Solve for x and I get x equals 22. So now if x is equals 22, I can plug 22 back in for this angle. That's 66. That angle is also 66. So now what's the measure of angle A? Remember, all the angles of a triangle add up to 180. So if that's 66 and that's 66, what's 66 plus 66? You should get 132. And so 180 minus 132, 48 degrees, must be the measure of angle A. That's how those problems work. Okay. Something else for us to know. What about an equilateral triangle? When I have an equilateral triangle, that means all the sides are the same. But something else for us to keep in mind. If a triangle is equilateral, then it is also equiangular. So if all the sides are the same, then we also know all the angles are the same. And if I measure this, so notice it just gave me the tick marks. Tick, 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 which means all my sides are the same. But if all the sides are the same, then all the angles must be the same. And so if they're all x, then x plus x should be equal to 180. So 3x equals 180, or x has to be 60 degrees. So if I have an equilateral triangle, then I also know it is equiangular. If it's equiangular, all my angles have to be 60 degrees. Okay, well, it also works the other way. So what if they tell you you have an equiangular triangle? What if you know all your angles are the same? Well, then we also know that it's equilateral. And how does that work? They give a, so if they tell me right here that all my angles are the same, that's what the shading means on this notes. If all the angles are the same, we do also know that all the sides are the same also. So now, what does the problem look like? Find the value of the variables. So it tells me all my sides are the same, but 3 sides of my triangle are the same. And if all my sides are the same, we have to remember that all my angles are the same. And if all the angles are the same, they must all be equal to 60. So 4y must be equal to 60. Y equals 15. 3x plus 15 must also be equal to 60. Solve for x and you get x equals 15. Similar problem. I have a little arc here, arc there, arc there. Well, if all my angles are congruent, it means that they're all 60. So it means I have an equal angular triangle. Well, if it's equal angular, it must also be equilateral, which means all my sides must be the same. So 2t plus 1, this side, must be equal to 4t minus 8. Do a little bit of algebra, subtract 2t from both sides, add 8 to both sides. I get 2t equals 9, divide both sides by 2, and I get t equals 4.5. Lots more examples to follow in class, but please be familiar with the concepts.